Welcome to Safety Chats. Host Jason Stark, Director of Safety at Baldwin Safety and Compliance, shares decades of aviation experience and a passion for safety. Let's get started with this week's Safety Chat.
Hey everybody, welcome to the Baldwin Safety Chat podcast. As I always say, this is the podcast where we talk about all things safety management, safety, occupational health and safety, anything safety, and even maybe spice it a little bit with some organizational behavior and system stuff, just to keep it interesting. Not that safety isn't interesting by itself. Having said that, today I would like to bring up just a little bit more system stuff. And the reason being is because I think this has application of what we do in our jobs to find failures or potential failures in our system. And it's not overly deep, but it's this idea. It's been bouncing around in my head a little bit. It's called the theory of constraints. And it's actually an interesting concept. And I guess one of the ways to explain it is when we look at a system, like what we work in. You look at a flight department, FBO, an airline, a 135 carrier, whatever it may be, we work in a system, right? And there's back and forth. We can work in a complicated system or we can work in a complex system. And we've talked a little bit about complexity, and you never know what you're going to get in a complex system, which makes one predicting. And that's why predictive safety is probably really nuanced, if not just outright wrong. But also why causal analysis is also hard and complexity. But we're not going to go down that road. Where I'd like to talk about, though, is in the system, the theory of constraints. What makes it interesting is that the system itself is not the sum of its parts. When we work in a system, it is not the sum of its parts. Actually, it's the interactions or interdependencies that matter the most in a system that ends up making it that the sum or the whole is not equal to the sum of the parts. And I'm sure we've heard that little catchphrase, especially in synergistic reference. But that's really crucial because the parts of a system are not only independent to some extent, like they have a function, but they're also very dependent on the functions and interactions with the other components. And this is where the theory of constraints come in. And what the theory of constraints basically states, and I'm really going to broad brush it here, but what it basically states is that the total output of a system is only as great as its most constraining element. And if you look at it in one of the examples, systems theorist actually teaches at USC by the name of H. William Detmer. One of the examples he uses is the idea of a chain. You look at a chain, each link is interdependent. And if you have a chain rated for 3,000 pounds, and let's say you load 3,000 pounds onto it and add a little bit more weight, one of those links is going to break first. And so you could say that the load or capacity of that chain is based on that weakest link. And I don't like using the term weakest link as much because it makes it seem like someone lower in the food chain, but it is that truly that weakest link. So when we look at a system, the total output or capacity of that system is dependent on the constraining element or the weakest element, if you will, or the element that doesn't have the amount of capacity. I promise you I'm going somewhere with this. Let's look at it in a purely technical system. Let's look at it, for example, in an assembly line. Let's say you have a machine that is receiving raw material, and then it's stamping this raw material into a widget. And it's putting out X number of widgets. So X being the variable, whatever that number is, 100 per hour, 200 per hour, whatever it may be. And then on the assembly line, there is an inspection machine, a machine that needs to test certain characteristics and qualities of this widget before it can be considered complete. And so let's go back. Let's say the capacity of the inspection machine is X minus 10, for example. If we're looking at an hourly rate, the machine, the stamper, is putting out X number of widgets, and the inspecting machine is only able to handle X minus 10. So in that given hour, you're going to have a buildup of 10 widgets waiting to be inspected. So over the course of 8 hours, you're probably going to have a backup of 80 widgets. So you can plainly see that the inspection machine is the constraining element. And so whatever that inspection machine is able to put out as the final product is truly the output of the system. And you can see how it's dictated. It is dictated by that constraining element. So let's have a little fun now. Let's put that into a social system or a socio-technical system. Let's look at our flight departments. And this is where I think we can find potentials for problems. Now, see, the difference is, in my opinion, that in a truly technical system, machines are machines. They're going to behave the way that they're programmed. So if that inspection machine can only handle X minus 10 per hour, it's going to behave that way until somebody adjusts it or they get another inspection machine or whatever. But when you get into social systems, we're human. And one of our human traits is, especially in the aviation world, I've noticed, is getting the job done. Let's put this into perspective of a flight department. Now let's do a 91 flight department. The board or the primary passenger, they have X number of hours that they can be gone from the office, right? They have X number of hours to travel, to go around the world, wherever it may be. Now, we have constraints in the flight department. In 91, they're more self-imposed, right? Let's say we have this BAO regulations or standards on flight time and duty. We may have, depending on if the output from the primary is in sync with what the capacity of the flight department, everybody's happy and we're in harmony. Now, what happens though is if the output of the primary, the passengers, their requirements exceeds the capacity. Now, we could say that, okay, those extra hours that they need to fly, they get backed up. Actually, they don't. So what happens a lot of times is that we will adjust. We will try to meet that mission and go above and beyond the constraint of the capacity. Can't even say this, too many C's. The capacity of the constraints we have in place. And what ends up happening, and we've seen it in flight departments again, we see duty time waivers to the flight time so they can do like a London and back trip or whatever it may be. So if we adapt to that capacity, then the system will adapt. It'll say, okay, we can adapt. We can get that throughput. And it becomes harder. And what you're doing is, because we're adjusting, we are adapting to take on more capacity when those constraints are put in there for a reason. Then we are running the risk, obviously, of having something happening. Now, a little different in 135, but we can still put this into the context of an unscheduled air carrier. Now, for example, we have dispatchers and schedulers, just as you do in 91. And let's say they're very efficient at booking trips. Demand is high. They're very efficient. They are selling the tires off airplanes. And what they're saying is that they're putting out X number of trips. And we are constrained legally, right? We have 14-hour duties, 10-hour flight times, 10 hours rest. Our constraints as far as how many days in a row we can fly is pretty weak in 135. So we basically have this baked in capacity. And what happens is that we see that scheduling, they have the ability to meet our capacity, but we also have another capacity, which is our human capacity. And things like cumulative fatigue and whatnot can be a problem. So we can see that we are adapting. Now, 135 regulations allows us to adapt, and that may or may not be a good thing. That's a discussion for another time. But we see that we have this output from our scheduling, from the demand coming into the flight department, and we adapt. We might have seen 135s. They try to improve quality of life. So they come up with these quote unquote hard, but not so hard days off. And what they see is that, well, if demand's up and they have to meet that capacity, they go around those constraints and they end up obviously trying to meet that capacity of the system. And then what happens when they've completely optimized, they go right to the stops of what 135 will allow. Either they have to turn down trips, they hire more pilots, or they start making flights disappear on the books. And I've unfortunately been in all three kinds of departments. The latter is not a good one, and it is illegal as well. Anyway, in maintenance, same thing. Let's say that we have a high demand. We're breaking airplanes. What we have coming from our flight department element is what the input is to maintenance. Maintenance, unless they are proactive, they don't have any duty time limitations unless organizations implement those, which is a good thing. But what you next see is that you have one mechanic trying to meet this capacity, and they're coming out in the middle of the night. And so we are constrained, but we try to adapt. See, with one mechanic, we should be constrained. We should be constrained to an 8-hour day or 9-hour day, whatever it may be. But what happens is that if our output from the flight department is pretty high, is X, then the capacity for the maintenance department, if this were purely a machine, the plane would sit there until the machine, the maintenance was ready. But because we are human, we tend to adapt. especially when it means meeting the mission or, at the very worst, keeping your job. Same thing with FBOs. We look at, especially during times of high surge, we have flights coming in, and that's the output of the flight, and it becomes the input into the FBO. The FBO only has so much capacity. That is the constraining. If it were a machine, the planes would just back up on the taxiway until the machine was ready, which does happen sometimes if truly the capacity in terms of real estate is met. But when it comes to the human, we adapt. We go to longer shifts and we can have a problem. And I hope we're seeing, though, that this may be a good place to look when we're trying to identify potential failures in our system, that we can look at what is being fed into in terms of what our element of concern needs to process. If that is something that under normal circumstances, under the constraints that are in place, if it exceeds, that means we may have a tendency to adapt. Now, 135 is a little bit more tricky because 135 regulations, especially rest and duty regulations, in my opinion, this is only Jason Stinky. You probably knew how to say that. But in my opinion, the 135 rest and duty regulations are weak at best. And I don't think they take into consideration what the human body and the human individual can handle. Now, some of you out there, maybe you're like true cargo dogs, freight dogs. It's not a problem, but you know what? It can be. And so 135, I think, allows almost too much capacity into the flight, and which then requires us, we have no constraint in place other than 135, unless, of course, the flight department is active. So having said that, how do we identify this and what do we do about it? And this is really cool, but there are principles to constraint theory. So there are principles that we can apply in order to first find the problem and then do something about the problem. But I think what's going to happen is probably already in your head. It is common sense. So this came from Goldrat, again, another systems theorist, and he came up with 5 focusing steps. So the first thing is we want to identify the system's constraints. And what we see, at least I've seen, it's usually the flight department or the maintenance department that will be your constraining, because there's a high demand, especially now, there's a high demand for lift. And as such, there's going to be a high demand to maintain the airplanes. And obviously, when we look at the job market it is now, that capacity could be fluctuating and it could be a really tenuous spot. But first, we want to identify the system constraint or the constraints. And then the second one is decide how to exploit the system's constraints. Now, this one we have to be careful. And what that second step is saying, this one is to optimize output. Okay. And again, a lot of times in truly technical systems, but even socio-technical systems, we want to look at that element and say, are we doing everything to squeeze the most amount of capacity within the constraints? Though we can't forget that, because we could say in 91 that, are we flying them 24 hours a day? Are we truly getting all that capacity? Because there are no duty times regulated. Now, we do put SBAO ones in there, and unless we stay true to those, we're an open book. And then same thing with 135. We could say, okay, are we flying our guys truly to the max? Are we doing the 14-hour duty days? And you have to forgive me, I forget how many days off you have in a month. You guys are probably screaming it at the iPod right now or whatever you're listening to this. But we could say that's how we're exploiting the system. But we have to ask the question, do we want to exploit the system constraint-free? Or even if it's regulatory constraints, do we truly want to do this when we're dealing with humans? So I will submit a subset in there to say how to exploit the system constraints so it's getting the max capacity, but within constraints that are commensurate with human performance. I want to put that little caveat in there. So I can't believe I just added to Goldrat, but don't tell him. So how do we exploit the system constraints? How do we get the max capacity in the constraints that we have that make sense to human performance? So if we go right up to the constraint for human performance, we're maximizing capacity. If we go beyond because either the reg says it or because we don't have a standard, then we're getting into trouble. And I think you guys would agree with that. Now, here's my favorite step, and I'll tell you why. Number 3, subordinate everything else to the above decision. So what that's saying, and this is very important, what that is saying is that if you have optimized that element, and again, with my little caveat that within the constraints of human performance, what makes sense, and the constraints that you put in place. If you are optimized and you notice that the capacity is still high and there's still a high demand putting pressure on your pilots, on your mechanics, then it's saying that you need to subordinate that one element to the constrained element. So we either got to tell them to stop scheduling so many flights. You've got to tell them that we are not going to get all those airplanes in. You're not going to have that airplane by Tuesday. The annual's not going to be done in the next 5 hours. The phase inspection's not going to be done in the next 2 days. You're going to have to miss that trip, which some of you might be cringing right now, so bear with me. But when we want to optimize the system, and this is when we have to deal with the theory of constraints. So in order to deal with that, to prevent that backup, or to prevent, in our case, the demand to adapt and go beyond performance limitations, we have to subordinate the other input elements to whatever the capacity of that constrained element is. Now, if we've constrained the elements, now we'll notice that we can't sell as many flights. We can't fix as many airplanes if we're going to stick to steps 1 through 3. Number 4 is elevate the system's constraints. That means hire some butts, get some people in there. I know in this job market, I'm being very flippant and saying just hire a pilot or two or hire a mechanic or two. Not easy. So building capacity in the organization, sometimes we have to get creative. Sometimes we have to look outside of pure hiring. Sometimes we have to build temporary capacity, which is a perfectly sound organizational strategy. So maybe we have to look at contract pilots, and big asterisk there, make sure they are vetted and make sure they meet your controls and your requirements of your pilots. And same thing with outsourcing maintenance. We may need that temporary capacity if we want to increase the capacity of a given element and maintain our constraints on safety. You guys following me? But it's elevate the system constraints. Now, number 5 is a warning. If the previous steps, a constraint has been broken, go back to step 1, but do not allow inertia to cause a system's constraint. What in the world is that saying? What it's saying is that if you've now fixed that element, that it no longer is the constraining element. What the constraint theory says is now you're going to have a different constraining element because you've optimized that element, which is great. But remember, systems are interdependent. So if you optimized one element, that could actually be a detriment to another element. So it's saying run this whole stinking thing all over again and look at what that constraint is. So it could happen. Think about it. If you say, okay, great, we're going to sell trips. We're going to go nuts. Now we could say, all right, we're going to keep our constraints that we have in place. Whatever it be the ISBEO or the BASC or whatever MBAA flight and duty rest guides, or we're 135, but we're going to honor hard days off and we're going to fly no more than 10 days in a row. We're going to honor those constraints and we are at max capacity. So right now, because of step number 3, we subordinated, we're having to turn down trips or farm them out to another certificate holder. We're not making our crews adapt because they can. We are honoring that. So we put a constraint on the number of trips we're going to sell based on our flight department's capacity, that including the constraints that we have in place dealing with human performance. But we want to increase our own capacity so we can quit farming out all these trips. So you hire 5 pilots and you bring on another airplane, whatever. Okay. And now you're like, well, holy smokes. Okay. So now we have increased the capacity. We have now matched the output of the input from our scheduling, from our sales. But now we have to think, okay, what about maintenance downstream? Now, is that a constraint? And we have to say, okay, these planes, they're going to need phase inspections. They're going to need unscheduled maintenance. They're going to need whatever, servicing. Have we fixed that problem? Now, do we have a constraint in maintenance? If we do, we run the whole exercise again. Are we getting the maximum out of them? Are we honoring the human performance constraints? If so, then we're going to have to subordinate that input. We're going to have to tell the flight department, hey, your plane's going to sit there for a little bit. We'll get to it, but we just don't have the manpower for it now. And we're going to honor our human performance limitations. And they say, okay, now we're going to hire 2 mechanics. Fantastic. So now the capacity has increased in that element. Now the planes are getting fixed and wonderful. We need to look at the system again. Okay, now where could have that constraint moved if it did move? And the game continues. And that's how it happens. And so that's the theory of constraints, basically, in a nutshell. But I think what it really shows is the dynamicism, is that a word? The dynamic nature of systems, in that when we look at a system, we can't just look at one element and fix it. We have to look at the entire system. and how the elements are interdependent. And I think with the theories of constraint, that's one step towards it, especially when we start looking, okay, what are the demands being imposed on the flight department? And is it causing us to exceed human performance limitations? Now, if you're exceeding regulatory limitations, you got a different kind of problem and you got to stop it. But even in 135 regulatory constraints, I don't really know how I feel about that, but you have to still look at human performance limitations. Are we exceeding that? Or do we have the potential to exceed that? And if we do, well, then we need to start looking at the system again. We need to see, okay, are we completely maximized? We can get creative. We can get creative with scheduling, but are we completely maximizing our capacity considering our human performance constraints and to some extent quality of life? If we are, then you either need to decrease the input, subordinate that other element to the constraining element, or increase the capacity of that element. But where I think this is gold for us is to look at those interdependencies. And if we see a pressure from one component with putting out a lot of capacity going into a component that doesn't have the capacity, in a machine system, that'd be easy. We see it pile up on the assembly line and we say we need to do something. But not so easy in our organizations because we like to adapt. We like to succeed. We like to get that mission done. So my challenge to you all is to look for those in your organization. And if you find them, go through those 5 focusing steps. Again, identify the constraint. Decide how to exploit the constraint. Make sure you're getting full capacity out of it, considering Jason's asterisk within human performance limitations. Subordinate everything else to the above decisions. So that means you're going to have to reduce the output going into that element and elevate the system's constraint. If you want the same output, you have to increase the capacity. We can either increase it internally or we can go to external sources to increase capacity. And if you have solved that constraint, do not sit back all fat, dumb, and happy. Look at the system again, because now you have another constraint, more than likely. So I hope this was helpful. I guess I've talked about systems a few times. I think systems are really cool. And I think systems really have, in systems thinking specifically, a really big implication in safety management. It's really hard in the systems in which we work. And let's just confine it to the organization now. I'm not even going to get it into our environment and the system of the NAS, but in the organization that we work, it's really hard to take a reductionist attitude. And what that means is that we pick the system apart into pieces and focus on one piece without considering the other pieces. That's dangerous, but also fascinating. And that's what makes systems so cool. And why I think that as safety managers, if we can become more proficient at thinking in systems, that we're going to be very successful. And thinking in systems also has not only implications just in safety management, but just in general. When we look at our operations and our organization and even the national airspace system, when we think in systems, it's really helpful to really identify potential problems. So that is my jive for today. And I hope, like I said, that it is of some use. If not, let me know. If it is, if you're digging this podcast, do me a favor and just hit that like button wherever you listen to it. We want to serve you. We want to give you a podcast where you can come just to find some interesting information, practice critical thinking, get some knowledge where we all can learn together to do our jobs maybe just a little bit better. But thank you so much for what you guys do out there making things safe. I applaud you. I appreciate what you do. And I hope you come back. But until, stay safe.
This podcast is brought to you by Baldwin Safety and Compliance, the leader in safety management for the transportation industry. Since 2004, Baldwin has been providing state-of-the-art solutions and 24/7 support to the aviation and transportation industries. Baldwin's clients include all sizes and types of transportation operators. Baldwin provides safety and related business services to commercial and non-commercial transportation operators, medical transporters, FBOs, MROs, airports, flight schools, UAS operators, firefighters, OEMs, ground transport operators, and others. Visit BaldwinSMS.com to discover how Baldwin can enhance your organization's safety program.